Computation of slope angle and slope aspect. Now, what is the slope angle? You can see in the figure, it is the angle alpha. This is also known as a slope gradient, and it is the angle between the path P in the horizontal plane and the sloping terrain. So you can see that the path P is shown over here as delta P, and then there is a sloping terrain which is delta F. This I had explained before that the delta P which is shown over here is the run and delta F is the rise. So the slope angle is expressed in elevation as elevation gain in the percentage, how much elevation has been gained. So either it is shown in terms of percentage or as a geometrical angle, but that angle is given either in degree or radians. So you can see here what is the slope percentage. It is delta F by delta P into 100. So it is delta F upon delta P into 100. Whereas the slope angle is given as arctan of delta F by delta P. Now, how do you get that? Because you can say that tan theta, in this case theta is alpha actually. So tan of alpha is equal to opposite upon adjacent. So your opposite is delta F and adjacent is delta P. So alpha, if you want to find out what is alpha, it is the tan inverse of delta F by delta P. That is the arctan of delta F by delta P. So this is how we got the slope angle alpha. The path P is chosen as that path which will provide the highest slope angle value. So it can lie in any direction, and it is that path which is providing you with the highest slope angle. So you can see in this figure here, this is the path P which is following which is that path at which the angle of the slope is the highest. So with respect to the north, whatever angle is made with this downward slope path P, this angle is called as the slope aspect. So starting from the north direction, we make an angle which reaches this downward slope path, which is having the maximum slope angle, and whatever angle is made with the north to this path is called as the slope aspect. So in this figure you can see that omega is the angle which is made from the north direction to the path P. This is the slope aspect, whereas the slope angle is alpha, which is made by the slope on the path P. So let us now try to understand how to compute the slope angle and slope aspect in a raster environment. So if you have an elevation raster which is showing you the elevation of different cells, then how do you compute the slope angle? So every cell in the raster will have its own elevation value plus the elevation value of its 8 neighboring cells. As shown in this figure. So you can see in this figure B, this figure is showing the X gradient filter, whereas figure C is showing the Y gradient filter. The X gradient filter shows the slope increase ratio from west to east. So this cell is showing the west slope and this is the east slope. So what is the increase ratio from going from the west to east? That is shown by your X gradient. So this figure B is showing the X gradient. So let us suppose that the west cell is having the value of 1540 meters, 1540 meters, and the east cell is having the value of 1552 meters. So the difference between the west cell and the east cell is of 12 meters. 12 meters. So you can understand that there is a 2 cell difference. So per cell there is a 6 meter difference. So the cell width is of one cell width is of 6 meters. Now coming to the Y gradient, that is figure C. In Y gradient there is an increase in the slope from the south to the north. So Y gradient shows the south-north slope difference. So both these filters are expressing the elevation gain per cell width. So if you use the derivatives, delta f by delta x and delta f by delta y, f will stand for the elevation field. It is a function of x and y. So for example, delta f by delta x will be the elevation gain per unit length in the x direction, and same way delta f by delta y is the elevation gain per unit length in the y direction. So here we have delta f by delta x, elevation gain per unit length in the x direction, and same way we can have delta f by delta y, which is the elevation gain per unit length in the y direction. So now we want to obtain the real slope angle alpha along the path P. Let's look at this figure now, which is going to show you the slope aspect, how to calculate the slope aspect. As you can see in this figure, delta f by delta x is showing the elevation gain along the x-axis, and delta f by delta y is showing the elevation gain along the y-axis. So, and what is this elevation? This elevation is along the path P, at which there is a maximum slope angle of alpha. Now, when we try to find out what is tan alpha is going to give you this elevation that is opposite upon adjacent, that is P. So the opposite upon adjacent is going to give you the tan alpha. But as you can see over here, whenever we calculate the slope, it is always the rise upon the run. So this tan alpha is in fact going to give you the slope with the slope angle of alpha. Now when you try to take this slope tan alpha, that means the slope at this place is tan alpha. Now when you take this tan alpha and when you take the slopes of other two sides, you can see that it is forming a right angled triangle. So here we have this slope as tan alpha this slope is delta f by delta x. And what is this slope? This slope is actually coming from this side. You can see that this is delta f by delta x. So this same slope is carried over here as delta f by delta x. Now if you look at this triangle which is formed here, it's a right angle triangle. Since it is a right angle triangle, this becomes the hypotenuse. So I'm just going to mark this in another color. This is your hypotenuse, and this hypotenuse is actually the slope at the path P, which we have just found out. It was tan alpha. So tan square alpha, that means the hypotenuse square, will be equal to the sum of the squares of other two sides, which is delta f by delta y square and delta x by delta y square. In other words, if I just take tan alpha, then it will be equal to the root of delta f by delta x, the whole square, plus delta f by delta y, the whole square, and this will all come in the root side. So this is what we are going to get. Now moving forward, let us now try to find out what is this angle omega. I'm sorry, this is tan psi. So what is tan psi? Psi is the slope aspect, and we are going to try to find that. So what is tan psi? Tan psi, this is the angle psi. So tan psi is going to be opposite upon adjacent again. So that is going to be delta f by delta x upon delta f by delta y. So you can see over here in this formula. So what is psi? It is the tan inverse of delta f by delta x by delta f by delta y, that is arctan of that. So this is how you can find out the slope aspect. So what are the steps that are performed? First thing is we take the input elevation raster R and we compute the x gradient and y gradients using the filters which are provided in figure B and C. So we find out what is the x gradient and y gradient. I'll show you the tables here. Later on, these x gradient and y gradient in the step 2, they are normalized by dividing by the cell width. So as I have told you that suppose this cell on the right hand side here, this cell is having the elevation of 1552 meters and this cell is having an elevation of 1540 meters. So there is a difference of 12 meters. And if you know that the cell width is of 6 meters, that means there is a difference of 2 cells. So since there is a difference of 2, if you normalize this difference of the slope, it will go from -1 to +1. So that is the reason why after normalization the x gradient filter is showing -1 and +1 in these two cells. Similarly, we can find out the y gradient filter also. So that is our step 2. The step 3 is by using these
two rasters, we are going to find out a third raster. That means that raster, that is the output raster, is going to show the slope angle alpha for each cell.